Okay, it's been a long time since I did a video, so let's see how this works. I'm away at a conference, so hopefully you guys can look at this on OneNote and listen to it on headphones and it doesn't interrupt everybody else in the class. But the main thing about 6.4 is the side splitter theorem. You explain how and why the proportional sides work in the side splitter theorem. We've been talking about oodle, we've been talking about being consistent with labeling your proportions to solve problems in these triangles, and the side splitter theorem is no different. Now the corresponding angles or sides, alternate interior, alternate exterior, all of these words right here are all review stuff you should have, you should know. But here's a review of these definitions. A similarity statement is like a congruent statement. We're going to use oodle, oodle being order of the letters. Be consistent with the order you go through. That's why oodle is important. And a similarity statement is the same type of thing. And there's a review of what slope is. Now in class, I want you to review, come back to this after you get done with the video, and add these questions to the task in the vault notes you should have already copied down. When I get done talking about the rest of the video here, you should be able to come back and answer those questions. So remember to come back to here and write those down. Okay, here's what the task entails. The task is talking about a bunch of parallel lines intersecting this triangle. Now remember, B, C, and J, they are all corresponding angles, so they're all congruent. Same thing with D, E, and K. They're all corresponding, so they're all congruent. Because of that, we have a bunch of similar triangles. And let me show you what I mean. This is the smaller triangle, and then I have, if you block out this line, you have the medium triangle, and then you have the large triangle. Because you have a bunch of corresponding triangles, you can write a whole bunch of corresponding proportions, like side over bigger side equals side over bigger side. That's what this one is. And then AB over BD. You have small side over small base, AC over CE, equals medium side over medium base. AD over BD, let's see, AD over BD, AE over CE. And you can extend that down here with the JK line as well. So remember, be consistent, and you can write down all kinds of proportions on here. Now the question is, how does that go to the side splitter theorem? This proportion down here, where is it? Oh, right here. BD over AB. Just BD over AB, does that equal CE over AC? And the answer is yes. These lines split this up proportionally, like you're going to see this on a set problem. This part over this one equals this one over this one. So parallel lines cut triangles and cut these lines proportionally. Okay, so this is a really cool proof I added on the OneNote. Make sure you look at that. That's it for the task. Let's talk about the RSGs real quick. Here is the ready problems using the Pythagorean theorem. Looks like you have to find the hypotenuse there. So add those squares, right? This one looks like you have to find one of the legs, so we would subtract that square from that one. Okay. And here I have similar figures. Be consistent when you write down your proportions to solve for that unknown side length. Okay, here is a bunch of side splitter theorems. Be consistent when you're writing down proportions and solving if necessary. Same thing for number 12. You've got 3 different parallel lines right there to be consistent when you're writing down the proportions. Lastly, if you drew, like you can see on OneNote, if I drew this triangle and this triangle and this triangle and this triangle, you see how those are all parallel lines, all have the same slope? That's what they're trying to get across on similarity and slope triangles. Okay, that's all for this video.